Alright, some of you had questions for me, like, why do you think you are the right person? Why are you doing this even? Like,
Who are you?
Who? Who is but the form following the function of what, and what I am is a man
with
Skills are a very particular set of skills. Skills I've acquired over a very long career. Skills.
those are from V for Vendetta and Taken for the Unknown. These are the two best movies, hands down, for me personally. What a way to combine these two scenes, right? What's up, everyone? Hope you're doing well. Come for the drones, stay for the prototypes. But before we get started with the prototypes, let me introduce myself. I'm Karthik Rangarajan, founder and CEO of Agam Robotics. I'll put the link in the description. You can check out the website. I did my master's in robotics from New York University back in 2019. This is me here. Since then, I've been working as a robotics engineer in New York for the past 3 years and still working as a consultant. But now I'm back to India to focus on my startup to build a truly made in India drone components and drones, specifically consumer camera drones or quadcopters. I've been into drones or in general radio control since 2013 when I made my first vertical takeoff and landing VTOL aircraft for my engineering project. This video is like from 10 years ago in our college. I guess it was taken on a Nokia smartphone from a friend of mine. So apologize for the video quality. This is one of the only footage I have. Since then, I've built many different quadcopters or drones and RC planes like this, and this. I had a lot more of these pictures on Facebook, but a year ago, I actually deleted my account. My team and I at New York University built a robotic snake which can shapeshift based on the needs specifically designed for warehouses, for carrying crates or packing, or if there's like a shipment and so on. We also built a baby stroller for New York City people which can assist parents in carrying their baby strollers on the stairs. Note that it was part of our entrepreneurship course. And this stroller was like a hit, and our professors liked it so much that they offered us to continue working on this as a product. But being on a student visa, many of us were not able to proceed with that. So we threw the offer and took a full-time job. The idea of camera drones before going to New York and the learnings about startups gave me a clear and concise thought process of how I need to proceed with building my startup. And here we are. I'll put my socials in the description, like my Twitter, Instagram, and LinkedIn handles. I post a lot about startups on Twitter, so you can follow me if you like and get a daily dose of my rants about startups or hardware startups in general, specifically in India. Now the important part I know you guys have been waiting for. Let's look into the prototypes. We'll look into the designs and prototypes now. It's mostly 3D printed parts. I'm here to receive the PCBs. First things first, let's get the elephant out of the room. As you see here, this is the drone frame prototype. It's mostly the body and the arms. And these are the design iterations I've gone through. And as you can see here, it's a foldable drone design. You can like flip it open. There's a spring on these hinges over here, and it gets locked in tightly. And as you push it, it swings up and gets into that position until like it's passed through a certain limit, and then it snaps off. So as you can see here, it's one of the arms missing. I'm still like it to receive the spring for this, and once it's mounted, it should look something like this here. And I'll also be getting new motors for this design. I just had 3 of these motors, so I just wanted to see like how it fits. And this is how the design is going to be. And all these motors would be soldered to the ESC over here. I've made some design changes on the body over here. The ESC is going to be here, and this slot, what I made is for a sensor board. Instead of this, it would be moved over to the end of the drone, and in the front there would be the ESC and sensors on the back. And then we'll have the flight controller. What we have designed, we have looked into the flight controller in a glimpse. So we'll get into the details of those designs once I receive the PCBs, but that's going to fit inside over here. And the GPS unit, which is the future plan of the board design, is going to be coming up over here. And the battery pack would be mounted on top. So this is the foldable drone arm design we have come up with. So let's get this out of the place, and we'll look into the next set. These are the different iterations on the drone arm. Very initially, because I wasn't sure the plastic material strength, so I started with PETG, and I just designed it based on the injection molding. It looked like a 3D printed part of the injection molded design is not going to have much strength. As you can see here, it's very flimsy. But with the same design, if it's printed, if it's manufactured on an injection molded machine, this would have a greater strength. So just for this case, because of the prototype, since we are designing it on a 3D printer, I had to make it slightly thicker. So these were the different iterations we have gone through. And you can see here, there were the top and bottom plate has been made thicker, but still it had some sort of flexibility. And then we moved on to, I'll just keep it this way. And then we started adding the tabs over here, as you can see here, to sort of reduce the flex. Even then there was a strength issue on these hinges here. So there were minor changes in the design. We started making it beefier. I made different design strength. As you can see of the hinge here, it has a very small tab. So that was made changes to make it slightly bigger, so that it adds extra strength on the hinge, so that when the drone crashes, right, when it's open, and in cases of drones crashing, this would have a larger impact when it touches the ground. So it needs to be much stronger than it really is. So we had to make changes on these designs here. And then I saw that having the small tabs made it little flimsier. So I started adding more slots and thinner tabs. That also did not make much changes. It still had sort of flexibility. And I made some changes on this one where the wall, I'm not sure if this is clearly visible on the camera, it's slightly curved on the top edge to make it thicker in order to reduce the flex. This was really rigid, but the problem is that it's quite heavier as compared to the current design what we have here. That added more material, so it was getting quite heavy. And so we had to get back to the traditional design. And this was another design I came up with. It's completely enclosed, and this also added more weight as compared to this one. Here in this design, the slot wherein the motor wires get in, so this had a very thin slot, and the wires would just slide in. But if this was an injection molded, it would be quite smoother inside, and you can insert the cables. Because it's 3D printed, it had some rough edges. It was very difficult to get the wires inside the slot. So this was not a good idea. And the final design is something going to be like this. These are quite old for the longer length. The problem was, since this was smaller, it made sense to have few tabs and so on. But for the longer arm, it had more flex. It just did not make sense for a longer arm to be as rigid as it should be. So we came up with some modifications, added more tabs, as you can see in the final design here. So at like the wire routing going through over here, and the tabs at the end of the hinge would have been like slightly bruised here, because as the arms closes, the wire would get like rubbed. So I had to make some design changes over here so that wires would just slide in as you fold the arm. All right, let's look into the flight controller. This is the PICSOC 6 carrier board, and this is very similar to 5. So the carrier board for 5 and 6 are sort of like backwards compatible. You can have a flight controller from 6 added to a carrier board of 5. So this design is quite modular. I don't have the flight controller to show you guys here. I'll add a picture so that you get an idea of how the carrier board and flight controller is. So the flight controller, what we are designing, is going to be sort of backwards compatible. So if some of the users, or some drone companies, if they're already using the Holybro or like any other brand of PICSOC 6 or 5 carrier boards, they can take our flight controller and just like snap it off, and there are certain settings on the firmware side. So we'll like look into that when we get the boards. But it's quite easier to swap back and forth. This is the whole idea of PICSOC Autopilot Bus, PAB form factor, wherein the PICSOC 6 or 5 could like directly sit into a PICSOC 5 or 6 carrier board. So this is one of the design of the carrier board from a company called Holybro, and we have seen we have seen a glimpse of this design on a simulation or like in the 3D models. We are yet to receive the boards, as I mentioned. So this is the changes, and this obviously this board wouldn't fit here. Our design is going to be slightly different. The major design changes are that the connectors which are on the top here is going to be on the sides, so that like when it is installed on a drone, the wires are not like flexed too much and there's like a strain on those cables. So it would rather be on the side so that it's easier to plug in and it doesn't have like much strain on these cables. And these are some of the design changes I've come up. Once I get the board, we'll do a form fit function test to make sure these designs are perfect, or if there are any changes necessary. So once we get the design changes done, I'm sort of thinking to get these injection molded. I didn't have like a quote, but the tooling costs for injection molding is like too expensive. It's like 2 to 3 lakhs of tooling costs, but manufacturing of these are quite less. Once you get the tooling done, you can use the same tools, unless like you don't make any design changes. You can mass produce these cases. So these are the things which we have gone through with the prototypes.